Hello dear students, welcome to the topic ionic or electrovalent bonding. Bonding is nothing but a kind of friendship which is struck between two atoms in order to get stabilized in nature, in order to be able to exist independently in nature. Just like in a class, a student cannot remain isolated. You cannot be sitting all alone all the time. Yes, you can have moments where you are sitting alone, but all the time you cannot be doing that. You need another partner to share, to spend time with. The same thing happens in the case of atoms. In order to exist stably, in order to exist with their peace of mind in place, they need a friend. This type of friendship is what we call as bonding. This bonding between atoms happens by involving what we call as electrons. There are various ways that these electrons can be used to form bond between two or more atoms. One of the ways is by the formation of ionic or electrovalent bond. What is ionic or electrovalent bond? A type of bond formation between two atoms which involves transfer of electrons. Let's take an example where you have two children A and B. They want to buy a sandwich which is costing 100 rupees. A has 50 rupees, B has 50 rupees. Individually they can't buy that sandwich. So A goes and gives his money to B. Okay, I am not hungry. I have my snack box. So I don't need this money and I am happy to lend it to you. So A goes and gives his money to B. Now B has 50 plus 50, 100 rupees, is happy to go and buy the sandwich. A has loaned money to B. A similar scenario operates when we talk about electrons in an atom. When atom A here has 1, 2 or 3 electrons in its valence shell, it is happy to loan it to the other atom, which we will name it as B, the atom B. On the other hand, atom B can take up electrons if it has 5, 6 or 7 electrons in its valence shell. Now, valence, what is valence? This we've discussed in previous videos. I would advise you to see the structure of the atom part 3 video. The electrons in the outermost shell. Now, we are taking a very simple example to explain electrovalent or ionic bond. Calcium oxide. Calcium atomic number 20, oxygen atomic number 8. Electronic configuration 2, 8, 8 and 2. Oxygen 2 and 6. Here the representation that I have used is what we call as the Lewis dot diagram. In these diagrams or in these structures, we only represent the electrons which are present in the valence shell, that is the outermost shell. Now, calcium has 2 electrons in the outermost shell, which we have represented by 2 crosses over here. Oxygen, on the other hand, has 6 electrons, 1, 2, 3, 4, 5, 6 in its valence shell, which are represented with dots. Now, just to clarify here, crosses and dots don't mean that the electrons of the two atoms are different. No, electrons of all elements are the same. It is just for clarity that we try and denote it by different symbols so that it's easier for the students to understand. In your, while you are writing, you can also represent it the same way. It's absolutely fine. Now, calcium has 2 electrons here in the valence shell. If it loses these 2 electrons, it will now have 8 electrons in its valence shell because its third shell becomes the valence and it will get stabilized. It will be happy because it will have offloaded those 2 electrons which are extra with it. This is according to the octet rule which we had discussed in the earlier video. On the other hand, oxygen would have acquired 2 electrons from calcium, and now it will have 8 electrons in its valence shell, and this also is happy. Its tummy is full. Okay, I'm done. I wanted 2 electrons. I'm happy. Calcium had extra 2 electrons. Even that is happy. So it's a kind of a mutual understanding, and they have now struck a friendship because calcium has lost electrons. It acquires a positive charge. Oxygen has gained electrons, it acquires a negative charge. Positive, negative. You know that opposite charges in nature attract each other. So calcium and oxygen will attract each other and they will stay close to each other and form a friendship, which we technically term as electrovalent bonding. Coming back to the Lewis dot structure, calcium, 2 crosses indicating the 2 valence electrons, oxygen, 6 dots indicating the 6 valence electrons. The arrows indicate transfer of electrons from calcium to oxygen. Now calcium, which was otherwise supposed to have 20 electrons and 20 protons, is now left with 20 protons but only 18 electrons. That means it has 2 protons extra. This is denoted by the symbol 2 plus. So this calcium, 2 comes on the head of calcium, not in front of it. We don't write it like this. No. We write it at the head of it, called as superscript, with a positive charge. So calcium acquires a positive 2 charge. Oxygen, on the other hand, has gained electrons. As an atom, it had 8 protons and 8 electrons. But now, after gaining 2 electrons, it has 8 protons. Proton number remains the same, but the number of electrons is now 10. So it has 2 negative charges extra. So for clarity, what do is, we put square brackets over here. The 2 negative over here indicates the 2 electrons acquired by oxygen. Since in this bond formation, there is involvement of 1 calcium and 1 oxygen, that is, we don't write any number because it indicates 1. So 1 calcium combining with 1 oxygen. So giving us the formula of calcium oxide. Now if you recall the symbols and the valencies, how do we write the symbol for calcium? How do we write the formula for calcium oxide? Calcium valency 2, oxide valency 2, and we have the formula for calcium oxide as CaO. This transfer of electrons clearly explains the formula of calcium oxide as CaO. Calcium has lost electrons and acquired a positive charge. So it becomes an electropositive radical or ion. Oxygen, on the other hand, has gained 2 electrons. So it becomes an electronegative ion or radical. Here, this number also helps us to know the valency. That is why if you will correlate to symbols and valencies, the valency of calcium is 2 and the valency of oxygen is also 2. But it is the charges which are different. Their oxidation state is 2 positive. Oxidation state of oxygen would be 2 negative. Calcium chloride. Now calcium again, atomic number is 20. So 2, 8, 8 and 2. Chloride or chlorine, 2, 8 and 7. Now here, if you notice, chlorine needs only 1 electron. Right? In order to have 8 electrons in its valence shell according to the octet rule. But calcium needs to do away with 2. This chlorine says, I can only take 2. Calcium says, okay, please help me. Even I want to offload. Even I want to get rid of the extra electrons, so I can also be stable. So, okay, chlorine goes and calls another chlorine atom. So, each of them takes the electron from calcium. Each one of them, if you notice, is taking one electron, but two chlorine atoms are involved. So we have calcium losing 2 electrons, 2 positive. Each chlorine atom acquiring 1 electron, so only negative, but 2 chlorine atoms participating. Hence we put a 2 as a subscript outside the square brackets, indicating the number of atoms involved. Calcium, only 1 atom is involved, so we don't put the number 1. As you know, in algebra also, what do? We say 1x, 1y. Do we say like that? No, we just say x, y, indicating that it is just 1 calcium but 2 chlorine atoms involved. That is why calcium chloride formula becomes CaCl2. The valency of chloride is 1, valency of calcium is 2. Let's take another example, a third one, calcium nitride. Nitride, nitrogen 7, so 2 and 5. This is something interesting. Calcium says, I want to get rid of 2 electrons. Nitrogen says, but I want 3. So that way they won't be able to form a bond. Calcium is stuck on giving 2 nitrogen bonds, 3. How do we do that? So the calcium says, okay, I will call another of my friend and maybe another one. So we in all have 1, 2, 3, 4, 1, 2, 3, 4, 5 and 6 electrons to give away. Nitrogen is also very happy. Okay, I will also call one of my friends, my brother actually, 1, 2, 3, 4. 1, 2, 3, 4 and 5. 6 electrons to give away. 6 electrons required over here. Right? So in other words, in this type of bond formation, you will have 3 calcium participating and only 2 nitrogen participating in this. Now how do we make out this? You know, it's a little difficult because for a beginner, how will you know how many nitrogen are involved? So let's try and find an easier way to it. So calcium, we have 1 and 2 electrons. So 2. Nitrogen, on the other hand, needs 3. So the next common multiple that we have is 6. So 2 times 3 is 6 and 3 times 2 is 6. In other words, 3 atoms of calcium and 2 atoms of nitrogen will be involved in order to form a bond between calcium and nitrogen. Calcium in the process will lose 2 electrons, so 2 positive, but 3 atoms of calcium are participating. So 3 comes at the foot, what we call as subscript, something which is down. Nitrogen, on the other hand, will gain 3 electrons. So each nitrogen is gaining 3 electrons, so 3 negative. But 2 nitrogen atoms are participating, so 2 comes at the bottom called as the subscript. This explains why the formula of calcium nitride is Ca3N2. Now, it will be helpful for you as well as very good for you if you can try drawing the dot diagrams for these structures: sodium chloride, sodium oxide, magnesium chloride, magnesium oxide, magnesium nitride, sodium nitride, aluminium oxide, aluminium chloride, aluminium nitride. Basically what target is, instead of calcium over here, you replace it with sodium, magnesium, aluminium. These 3 elements you can try and you will have practiced enough structures to give you confidence in this particular topic. Now if you notice over here, you are getting positively and negatively charged species. We discussed at the beginning of the lesson where we said that there are strong electrostatic forces of attraction between oppositely charged ions. Breaking it up. Electro means coming from electron. Static means which is not moving. Here the electrons are remaining localized on the atom. So electrostatic, that means non-movable charges. Forces of attraction, that means between oppositely charged ions there are strong forces which are called electrostatic forces. It is these forces which are holding the ions together. They now form a strong bond, because of which they stay in the vicinity of each other. Because they stay in the vicinity of each other, they will not move about easily. That is why we find that ionic solids are usually hard solids. Like your common salt, if you see, it's an example of an ionic solid. Since there's a high force of attraction between them, in order to separate the ions, you will have to give it a large amount of energy. So if you are heating in order to melt it, you will have to give it a large amount of energy. That is why their melting point, boiling points will be high. They are soluble in water or polar solvents. Why? Because water molecule has ends which are positive and negative. We shall discuss the details of this in the third video in the series. So positive and negative charges are able to separate the ions, making it soluble in the water. They are poor conductors but good electrolytes. Now you'll be confused. I'm talking about conductors here and then electrolytes. Conductor means something which allows the current to flow through it in the solid state. Electrolyte means a substance which allows electric current to flow through it in molten state or aqueous solution. And in the process it undergoes a chemical change. So these solids, when taken in the solid form, do not allow the passage of electric current. But if I heat them to melt it, or we dissolve them in water or polar solvent, then they will conduct electricity. That is why they are called poor conductors but good electrolytes. Usually their reactions are carried out in solution form, in aqueous form. That is why these reactions are fast, because what will happen is the water molecule is already separated, or it has broken down these forces of attraction between the oppositely charged ions, so that the reaction can take place at a fast pace. Why? Because you see, the oppositely charged ions, they have been separated, they have been taken away, they were so glued to each other, and now they've been taken away. So they want some kind of a bond, they want some kind of an attachment, because they will not be able to exist without a charge. They will immediately have a tendency to attract opposite charges to themselves. They are so much charged. So see the nature, when they are as an atom, they cannot exist. They want to make friends. But now when they have struck a strong friendship, again they need to stabilize by combining with another oppositely charged ion. Again, I would repeat, please try the examples that have been listed in this video to get confidence in this topic. It is very easy. If you have any doubts, please feel free to comment or message me. I'll be happy to help you. For more videos, please subscribe to Learning Chemistry is Fun. Thank you and have a good day.